few words about me. As I was introduced, I'm living here in Warsaw, and I'm working as a developer at a company called Pragmatis. Nowadays, I do mostly JavaScript or TypeScript development. Previously, I was doing some Java, but independent of the technology, in our company, we really care about the code quality, quality of the code that we produce. So there are many ways to achieve this, good quality of the code. As of many, I will just, because of this presentation is about testing, I follow the clean code practices, and I do test a lot, especially using test-driven development. Because of this, I've wrote quite a few tests in my work. And just as an example, in the last year, for the front-end, for the applications, for the projects that I was participated in, there were around more than 3,000 tests. Of course, not every written by me, but based on those that I wrote and based on the experience that I had from those that I observed, I want to share with you some of my thoughts, some of the best practices about how to write better front-end tests. Now, I would have some examples in React, but if you don't know React, what I would be telling about is really technology agnostic, so you are good if you don't know React. So let me start with why I'm even testing. It's not because I like it or because I am told to do so by some manager or whoever. There may be many reasons, but the two most important for me are that tests give me confidence. Confidence on different levels. Confidence that my application is working as it should be, so that every functionality that I have to write is working. Confidence that when I'm doing refactoring, my application still works. All the functionalities that I already wrote are working. And confidence that when I'm adding new features, all those features that I already wrote and are working are still working. Sorry. And it's really also important to have this confidence in a team, especially when you are a new team member and you come to a code that you didn't write and you have to add a functionality and you might be afraid that you will break something. With good test set, you are immune to a situation like this because you know that it would work if only the test passes. So the other thing is that test saves my time. It might be contrary to the popular beliefs or what some people are saying, that testing is a waste of time or it takes too much time. I have to disagree with this. Testing is saving my time. Maybe not at the beginning when I have to write some more code, but in the long run, when I'm adding new functionality, I'm refactoring my code. I have this time saved by automated tests that I can run quickly and not have to worry about anything. And it's only true, of course, if the tests are properly written. So if they are not, it's actually a waste of time. I will show you a few examples on how to write better tests. But let me start with how testing should not look like. So in development, we have this name for code that is not of good quality, code smells. I'm gonna tell you about few test smells. I don't think it's an actual term, but I'm using it. So the first test smell, some indicator that the testing process as a whole is not of good quality is that when you are doing a lot of manual testing, it means that there is something wrong with the process. It not only wastes your time because you have to do this manually, but it's also error prone because you would never be as perfect as machine. So you can never be sure that repeating the test would give you would do the same actions every time. Next thing is that testing only to have 100% code coverage or something close to this is also not a good approach, because tests like this only give you they don't give you any confidence actually, besides that each line of your code is tested, which is not good. And the biggest one actually is testing implementation details. Now, what I mean by implementation details, it's as a simplest example, in React, you could write a test like this. So then you have some component, and you can set internal state of this component, or you can access internal state of this component and just verify that it's like this. The problem is there are many problems why you wouldn't do this. There are many ways how you could test implementation details. I would have few of them later in the presentation. But tests like this, the biggest issue is maybe you had this before, that you change your implementation, you did some refactoring, and you had to you have to fix your tests because they were broken. And this is the best indicator that you are testing too many implementation details. So it's really a recipe for a disaster, and it's also a waste of time. So in this case, if someone tells that testing is wasting time, then he's right, because you have to go over the test and rewrite it after every change. Now, testing implementation details is a bit like playing with Jenga. So if you know this game, you move the pieces around, and finally the tower that you build at the beginning collapses because it's not stable enough. So while in Jenga it's actually expected outcome of the game because it's just a game, while in testing version of a Jenga, these moving pieces that you have is a test that tests implementation details. And by adding more of them, you are making your constructions or your test set unstable. And there has to be a moment when this whole construction collapses. And while in Jenga it's okay, it's fun because it's expected. Then when you have this in tests, it's really painful feeling, and you can feel just like this probably after few tests. so it's not. It's really sad to happen to this kid, but the same could happen to you if you test implementation details. So be aware. So to say that it's just not just me, I don't know if you write in React, you probably know who Dan Abramov is. If not, he's the creator of REDUX. Now I think he works in a React core team, and it's just tweet from 2 weeks ago, and I was happy that he tweeted this because I could put it in my presentation. Basically, he said that testing implementation detail sucks because actually the testing implementation detail is something that user wouldn't be able to observe when he opens your application. So all the things that user cannot see, and I don't mean something like hidden button because you have to click a button, other button first to make it appear. But the internals of your application are not visible to the user, so they don't really have to be tested. Of course, they can be tested, but like the core part of your test should be testing things that user can see, so not the implementation details. And there are many ways to avoid testing implementation details. Using TDD may be one of them. So if you don't, just a quick recap of test-driven development, it's a simple process with 3 defined steps, as we call them, red, green, refactor. So we add the test, then we add as little production code as it's necessary to make this test pass. Then we do refactor, then we add another test, and so on, until we have our functionality finished, our application finished. And this approach has many advantages. First of all, it gives you a lot of confidence. After all, your whole code base, if you are following TDD from the start to the end, your whole code base is thoroughly tested because you cannot write a line of implementation without writing a test first. As a result, but it's only just a side result, is that you have really good code coverage if you need this. And most important, the TDD serves you as a design tool. So it lets you use your application before you write it. And I don't know if you would ever write something that is hard to use, knowing that you would need to use it yourself. And it lets you look at your test as actually one of the users of your application. So if my theory is that if it's easy to use your application in a test, then it would probably be also easy to use your application by the actual user, because it's the same usage, just from different perspective, let's say. And this relates to the end, of course. By doing this TDD, you wouldn't be testing implementation details because you actually don't know them, as you haven't write your implementation before you have a test. So of course you can this, but it's harder. Now, this also relates to how, on which level we test our code. There can be different types of tests: unit tests, integration tests, functional, end-to-end, and many others. Now, when speaking about testing, usually people mean unit testing. However, what I have, we have this pyramid of testing where unit tests are the biggest. However, most of my tests that I write currently are integration tests. And why is that? So it's not like integration on the whole level of the whole application. It can be on the whole application, but it can be also on a page level, on few components level. Basically, it's the integration on a level that user would use. So as an example, if you have a login form, then even if you test that your username field works, that your password field works, that your login button works, it doesn't mean that your whole the whole login form would work. So why to test these things separately while we can test it as a whole, as a consistent unit that user would use. So this again lets you write from a perspective of a user of your application, and because of that, you wouldn't be testing implementation details, because the user wouldn't be able to see those implementation details when he opens your application. So as an example of this test, in React we have some component that we render. It's some list of users that you can search, and we are searching for all users that has name John, and then we just assert that we have those displayed users would have only those that have name John. So as a shortcut, I just put and now, based on this, I want to tell you about my road, or my team road to creating a better tests in general, but because we used React and React in our application, the better tests in React and ENZYME. But again, it's really technology agnostic. So this is how our test looks like currently. This is just a test to have like page with to-do items that you can search. So we have some initial items. We are just mounting or rendering our to-dos page. Then we are searching for all items that have text, and then we expect that our to-do items those displayed to-do items only contain those items that has test string in it. And so probably you wouldn't be able to tell if it's written in React, if it's written in Angular or Vue or any other framework or no framework at all. What I hope you can say is that it's rather clean. You can immediately tell what's going on in there, and that it's probably in integration, and whatever we used some internal state in here. If we use Redux, any other state management library, if we are doing any function we are calling, it is not important in the level of this test. It's just it's clean, it's easy to understand, it's easy to read by someone new, for example, in the project. So I actually make a wrong title for this because it's not almost all. It's only few of our mistakes that we made down the road to this. But let me just tell you about few of them. So first one, we are using ENZYME for our test, and it's a good library, but it has some drawbacks, and it has some functionalities that encourage bad testing practices. For example, there are 3 ways to render a test in ENZYME: by shallow rendering, by full rendering, and by static rendering. Now, what shallow rendering does is that it renders just the top level of the component, so it doesn't render any nested component that you might have within your component. I will show you an example in a moment. But as you might predict, it's really not testing. It's not giving you confidence. You are testing again implementation details because you are mocking these components that are behind, and it was really a nightmare when we used this shallow rendering in our test and we wanted to refactor our component. So anytime we wanted to add like another layer to our component, maybe some higher order component, or that we wanted to extract a component from within this component, our tests were breaking and we have to go and fix them. So as an example of this, we have some component that has list of items. We just check that we render 4 items with class item. And OK, it's working. But we now want to refactor it to extract the item component from within. And if we keep using shallow in the test, this test is now broken because this component find item.length is returning 0 instead of 4 because we don't render this nested component. So our outcome of this, we have a lot of these tests, and then we have to rewrite a lot of them in the process. And we decided to always render everything that is possible and not mock any dependencies. Because of this, you can have more confidence that your application is working whenever you are doing some change to your code, and like this. So the other thing that was problematic is that, again, in ENZYME, what you could do is you could find an element for a test. You have to find element for a test somehow. But you could use this syntax, so you can find component by its type or by its name. And again, I will be like machine repeating itself, but it's testing implementation details, because what if we change the name of this component? Then we have to go and change all the tests that are relying on it. So it's also a matter of testing of your application as if the user would use it. And instead of using some implementation detail, like in this case, the name of a component, you could use something that user can see. So for example, it can be a button, some text on a button, or it can be some label, it can be some placeholder, it can be something that the user would actually use to find your element, to find the element he wants to use on your page. If it's not possible, and it sometimes might be not possible, for example, we use some custom attributes that we can assign some meaningful value, and we use like data test, but it's only a convention. Also, IDs or class names might not be that. It's also kind of implementation there, but maybe not that much as component names. For example, it can be hard to use class names if you are using CSS components or style components. Then you cannot really find this element by the class name. So mistake number 3 was that related to the not testing the integration between different parts of our application. In this case, it's example with Redux. So what we did initially is that we tested our reducers separately, our components with mocked state separately as well, sometimes always selectors separately. But again, we had the situation, it was what happened to us is that we wanted to change the name of a property on the Redux store. And so we changed it, our tests for reducers failed, and we fixed them. Every test were running nicely. It was 100% green. Then we ran our application, it was not working. because we forgot to change this name of the property on our mocked store that we use to test our components. So that's like a different issue with testing implementation details. Previously, the tests were breaking because we changed something in our code, but now the tests didn't break, even though they should. So, you know, by having this this Redux store mocked with our component tests, we again lost confidence in our tests because they were not giving us the result that we actually should expect. As in this case, the test should fail. So we also started to testing everything, you know, as a one unit. In case of Redux, we just created a real store using real reducers. We, for example, use some Redux observables, so we use real epics for this. But it's not only Redux. It's actually any dependency that you might have. If you are using Mobix, it's the same if you are using any other state management library. If you are using React Router, if you are using internationalization or any other context, it's always better to test it as a single unit, because then you would be immune to a situation that you have a test, but it's not really giving you any confidence because it's not failing when it should be. So based on these mistakes and a few others that we made and our will to make this test as clean as possible, we came up with this idea that was our internal tool to make them to make the test cleaner. So we came up with something that we called later custom wrappers. I will in a moment tell you what it's about. So it's the same test that I showed previously at the beginning, and something in the middle, sorry, not at the beginning, with this to-dos page. So the key parts here are these methods on the component that I'm using, search to do items with text and display to do items. So they are obviously not functions methods that can be used on the component return from the ENZYME library. This is something that we added, and I will show you how it's done in a moment, but let me show you how this test could look like in pure ENZYME. So yeah, so I'm doing some mounting. I'm finding the element finding the search input by this data test, only data test here because finding by text in ENZYME is really horrible. And I didn't want to put too much boilerplate in here. And yeah, I also search for a input button. I click it, then I search for my to-do items, and I check that I have those to-do items that I should expect. Now, it's not that bad, but there is some boilerplate, and then it's one thing that I hate about ENZYME is this simulate change, that you have to provide this target value. And I cannot count how many times I made this mistake, and I was just putting some string as it was, or forgot about one of those or the order. So we created this tool that we use locally, and it's really nothing magical. So it's really just some few functions and few JavaScript objects that we again called custom wrappers because we wrap the ENZYME component. So what we do is when we have this mount to-dos page, we are using, there is some custom, our function mount with custom wrappers that takes as an argument the component we want to render and some custom wrappers, wrapper functions. Now these wrapper functions are just the pure functions that takes a component, returns an object with some wrapper methods that we can then call on the component model. And then within these methods, like this wrapper for to-do search and then search for to-do items with text method, what I'm doing is I'm doing exactly the same thing that I was doing in the pure ENZYME test, but we just added a few functions that are reducing the boilerplate. So instead of doing simulate change, then target value and text, we just created type text that is actually doing the same thing behind, but it's easier to use it every day. So it's really nothing more than just removing some boilerplate to making the syntactic sugar out of the ENZYME that we use behind. but we use it a lot now in our project, and it's really working. The tests are much cleaner, and it's really easy to use this library. So yeah, we decided to put it out, and if you like it, you can check it. If not, then you don't have to use it to write good tests. However, in React World, if you want an alternative for an ENZYME, there is this great library called React Testing Library that doesn't actually allow you to test implementation details, and it encourages you to test to write the integration tests. So you can check it out if you want, if you don't know it yet. But just an example, I tried to recreate this test that I had previously, but using this library, so you can see that it's also not that bad. Unfortunately, there is still this target value in here, but it's much better than ENZYME. Now, I was talking at the beginning that what I said, I hope, is technology agnostic, so those concepts of testing, not testing implementation, the concept of testing from the perspective of a user, so writing integration tests doesn't really apply to one framework or one language, that can be moved to others. And for example, in our company, we have projects in Angular as well, and in Vue. I think that's it. And the colleagues that are writing in these technologies are also writing nice integration tests that are clean, that are really easy to understand. And if the tools that we are using blocks us, then we try to adjust it. For example, in Angular, the basic, this library that is used for testing Angular, that is built in Angular, wasn't giving them enough power, let's say, to write the test that they wanted. So they just went and create small library that you can also check, and then let you again write nice integration test that doesn't test implementation details, like in this example. So we have some application wizard component, then we just performing some actions by typing some text into the name input, and then we are making a blur out of this input, and then we just verify that error that we display says that the application name cannot contain special characters because it has star in or asterisk in it. Yeah. So, but if that's not enough, then this library that I was talking about, the React Testing Library, so it's actually based on another library by the same man that is called DOM Testing Library, that, as name says, is operating on the pure DOM, so it can be used with any framework you want, with any and even in pure JavaScript, because unless the browsers would be changed, would stop using DOM, it would be valid for a long time. So, as a summary, there are a few rules that I follow when I write my tests. I especially use test-driven development. I try to not test implementation details when possible by writing these tests, especially the integration tests from the perspective of a user. Then I try to always, in my test, render everything to not mock any dependencies that I might then change and forgot to change in this test. And I try to verify actual HTML output that the user would see, the user of my application would see, and not some intermediate technology like JSX or whatever is used in any framework. Yeah, and I hope it was useful. Thank you very much.